Welcome humans, we're going to do the measurement lab. You should have this measurement lab answer sheet ready to go. Write your name on it, write the period on it, read the instructions at each lab station, and perform the measurement. So you're watching this because you may have misplaced it, or perhaps you were absent that day, so now you're going to be able to complete this lab. We're going to start with a graduated cylinder versus a beaker. It's a contest. What we want to know is which is more accurate and why. So our instructions are to measure 33 milliliters of water into the beaker and then into the graduated cylinder and find out which one is more accurate. It's important when we're taking measurements that we read from the meniscus. The meniscus is the line at the bottom of the curve that you see in a graduated cylinder. You must get down at eye level. You must look at eye level, because if you get up too high, your reading is going to be low. And if you get down too low, your reading is going to be too high. And that can make or break an experiment. So I'm going to start by pouring in water into my beaker. Okay, so I'm seeing here, I'm trying to get down at eye level. I'm seeing I'm at about 30. I'm going to use a disposable pipette to put it in drop by drop. Add a little bit more. I can see that my next mark is 40, so not exactly sure where 33 is on here. I'm just going to keep adding until I get... Alright, I'm going to stop about there and say that that's about 33. So I'm down at eye level. But it's so hard to tell exactly where the line is. Now I'm just going to pour this into my graduated cylinder and then add or subtract. So as you can see, reading from the meniscus here, right at the bottom of that line, we're not even actually to 30 yet. Whereas with this, we thought we were over 30. So because we're not even close, I'm going to use this beaker to pour some in first. We're right at 33. So the question asks, which is more accurate, the graduated cylinder or the beaker? And you need to answer why. One of the things I want you to understand about these pieces of equipment is what type of measurement they take. So a graduated cylinder and a beaker, they both measure volume. So what is volume? What is volume? You should be able to answer that question. Volume is a three-dimensional space occupied by a solid, a liquid, or a gas. So the units that we use generally are liters or milliliters, cubic meters, cubic centimeters, and then for people who aren't using the metric system, which is not us, but you might be using fluid ounces, gallons, and quarts. Okay, we're on to the first block. The first block, what you need to do is you are going to be measuring the length of the lab station from point A to point B, meaning from one side to the other. Your answer must be in centimeters, so you need to make sure that you're using the right tool for the job and that you're using the right measurements. So the right tool for something this long would not be a ruler, but it would be a meter stick. And we're not using inches. We're using centimeters and millimeters because it's more accurate. Now, we can see right now that this meter stick is not as long as the table, so we are going to have to make sure that we are doing some good marking. When we take a measurement, we need to make sure that we're starting at 0, not at the edge of the stick, but right where the 0 is. So we need to stand right over it so that we can see that it's at that 0 mark. So I have 0 there. We also have a 100 mark here, and I'm going to mark this with a piece of paper so that I know I'm in the right spot. So that's 100. All I'm going to do now is I'm going to measure from the edge here to this piece of paper's edge and add 100 plus whatever I get. Again, I need to start at the side where that 0 is. We're not starting from the edge of the stick, but we're starting from the 0 line. And then I'm going to push this up, and I'm going to just check my 0 mark. 100 plus, what is this? So remember, we're doing centimeters, and every small mark would be the decimal point. So if it said 50, which it doesn't, but we're going to pretend it said 50, and if it were at that line, it would be 150.2. Mark that in spot A. Or I'm sorry, spot number 1. All right, back to our graduated cylinder. We are going to find the volume of a marble using water displacement. To displace something means to move it out of the way from its original spot. So what we want to do is we want to record the initial amount of water that we have. And remember, we're reading from the meniscus. So we're starting at 30 exactly. So we are going to write down our initial amount is 30. Now we are going to subtract that number from what we get for our final number. So I have to tip this at an angle and let this slide. And then we're going to find our final number. Write that number down in milliliters. Now subtract the two numbers. That difference is going to be the volume of your marble. So final amount in milliliters minus initial amount in milliliters equals milliliters of the marble, and that is its volume. That goes in spot 2. So for number 3, we're going to take the mass of the marble using a weigh boat. We don't have a weigh boat, but this little paper cup will suffice. So the way that we do that is we need to use our digital scale. We turn it on. We make sure it reads 0. We put our weigh boat on, and we're going to hit 0 again. That's also called tare, T-A-R-E. 0 it out. And now when we put the marble in, it's going to give us the mass of just the marble. That is the mass of the marble, which you're going to put in number 3. Please remember that there are slides for this lab measurement lab that also show you step by step how to do the calculations and where to put the numbers. So spot number 4 is merely measuring the liquid volume that I've poured into this graduated cylinder. So I'm down at eye level for you, but I'll also go up so you can see some of the other numbers and get an idea where it's at. And then that way you can read from the meniscus. Okay, space number 5, we are going to find the volume of this book. So to find the volume, we need to multiply length times width times height. So length is usually the longest. And remember, we are going to start at the 0 mark, which so happens to be the very edge of this ruler. We're going to stand right over it so we have a reading. So in centimeters, make sure you're accounting for the millimeters as your decimal point. Mark that down. So that's a length. Here's the width. Mark that down. And then the height. So I'm going to need to get down to eye level to see this. I need to start at 0. Luckily, this starts right at 0. Mark your height. Multiply all three of those, and remember, you're multiplying centimeters times centimeters times centimeters, so that's going to be centimeters cubed. Your last calculation is density. So what is density? Density is just how closely packed the particles are in a substance. So if an item is not extremely dense, if it's less dense than, say, water, it's going to float in water. But if it's more dense than water, it's going to sink in water. So what we're looking for is the density of the marble. The calculation for density is density equals mass divided by volume. So you need to go back and take the mass that you found of the marble, divide it by the volume you found of the marble, and then it's going to equal a number with the units of grams per milliliter or cubic centimeters. Either or is fine. And put that in spot 6, and you will have your lab complete. Congratulations! Now turn that in.